school. This is your next session of your number system, exercise 1.3, 9th standard NCERT or CBSE syllabus. In the last session, we have completed up to 4 mains. We are going to start with the 5th main now. So, what's your question here? What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17. So children, try to understand the problem. What did they ask here? Do the division 1 by 17. So you are going to get a decimal value. That decimal is a non-terminating repeating decimal. Repeating means some decimals will be repeated, right? So how many digits, how many numbers will be repeated is your question. Okay, after 3 digits, same 3 digits will be repeated, or after 2 digits, same 2 digits will be repeated. So, after how many digits you are going to get your decimal as a repeating decimal is your question. So, in order to know that, we are going to start our problem. So, first what we need to do, children, here, we need to do the division. Okay, so 17. And I am going to take here 1. So, what you are going to do, let me take here, right? So, question you can write here also, no problem. So, now 17 table 1. 17 table, where you get 1? We can't. So, for that purpose, what I need to do, I am going to put a decimal point here and I am going to write 0. So, 17 table, do you get 10 children? No, 10 is smaller than 17. So, for that purpose, take 1 0 here and make this number as 100. Okay. So, now 17 table, do you get 100? Yes. Suppose if you take a decimal point, you want how many zeros you want, you can place here, right? So, now where you are going to get the 100 children, we are not going to get 100 in 17 table. But nearer number we are going to get. Where it is 17 fives. What is 17 fives here children? That will be 85. So 85. And now subtract this. What you are going to get? Carry 5. 9 minus 8 will be 1. So now you have put a decimal point here, right? So zeros, you can extend your zeros. How many you want? That many you can extend there. And take for every step 1 0 down. So now 150. Where you are going to get 150 children in 17 table? 17 8s are, I think, right? 17 8s are, it will be 136. So now let's subtract this one. What it will be? Carry 10 minus 6 will be 4 and 4 minus 3 will be 1. Right? Now drag one more 0 down. It makes 140. 17 table, where you get 140? Which is nearer this one only. That makes 8. So now 136. Now look here children carefully. So 140 minus 136 will be 4, it will be. Right? So now drag this 0 down. So now where you are going to get now nearer 40? 17 2s are 34. 17 2s are 34. Now again subtract this. 40 minus 34 will be how much? 6. So now drag this 0 down. Then what it will be? 17 table, where you get 16 nearer children? 17 3s are, it will be how much? 51. Right here 3 and here 51. So 60 minus 51 is how much here? It will be 9. So drag one more 0. That makes 90. So 19, 17 table, where you get 90? 17 5s are. 17 5s are 85. Then 90 minus 85 will be 5. Drag one more 0. That makes still how many you want you can drag, children, until you get a repeating decimal. So that is 50 here, right? There is no extension here. I need to take the extension of this division here. So now let me take here 50. So where you are going to get 50? 72 34. 17 2s are 34. So I am continuing this division, children. So now 50 minus 34. 10 minus 4 will be 6. 4 minus 3 will be 1. So now 16 we won't get in 17 table. So for that purpose, what I need to do? I need to drag in 0. Now what you are going to get? Where you are going to get 160 nearer number? 79 sir. What is 79 sir, children? It will be 153. Again subtract here. 160 minus 153 will be how much? 7. Drag one more 0 here. 70. So 70, where you get in your 70 table here? 17 4s are 68. So write the question here. 17 4s are 68. Again subtract. 70 minus 68 will be 2. Then drag 1 0 down. 17 table where you get 20. 17 1s are 17. Okay. So now how much here, children? It will be 17. 20 minus 17 will be 3. Now drag one more 0 down. See, until we get a repeating decimal, we are going to go on dragging this. 30. Where you get, children? 17 1s are. So 17 1s are 17. That will be how much here? That will be 13. Right? So now drag one more 0. It makes 130. So 130 where you get in your 17 table? 17 7s are. That will be 119. So yes or no? 17 7s are 119. So now subtract here. That will be 10 minus 9 will be 1. 2 minus 1 will be 1. So again drag 0. So here this is also not sufficient. Let's continue our division. Let them aside. So that will be 1 1 0. 1 1 0 where it is, children? 17 6 102. Okay. 110 minus 102. So how much it will be? 8. So 8, drag one more 0 down. That will be 17 4s are 68. So that will be 12. Okay. We go on doing division. Do you feel anywhere it is repeated? No, it's not repeated. So let's move on doing our division. Look here, children. Your 1 by 17 little I write up in order to write quotient. So now 12, right? So you need to drag 1 0 here down, and this 17 7s how much here, children? It will be 119. 119. So 120 minus 119 is how much? 1. So now again what you need to do here? Only 1 you got here. So I need to drag 1 0 down, put a 0 here, and one more 0 I am going to place here. Now look here, children. I feel it is repeated. Let's do the problem again. So 17 table, where you get number nearer to 100? 17 5s are. So 17 5s are how much? 85. 100 minus 85 will be 15 0. So like this, the division will be continued. So already in your question they have said it will be repeating. After how many digits it will be repeating? That's your question. So look here, children. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See here, after 16 digits, again your decimal is repeated. So what you can say, children? See, this is a non-terminating repeating decimal. Okay. So after how many digits is your question? After how many digits? 16 digits. So 1 by 17. So where you are going to get here, children? After or 16 digits will be repeated. You can say, not of writing after. Just you can say 16 digits will be repeated in this answer.
Let's look over your sixth problem here. Look at several examples of rational numbers in the form of P by Q. Rational number means it will be in the form of P by Q, and where P and Q are integers, Q cannot be equal to 0. Where P and Q are integers with no common factor other than 1. So I'm having terminating decimal representation. Okay, these P by Q fraction, when it is converted into decimal, that decimal is a terminating decimal expansion, it seems. Can you guess what property Q must satisfy? So observe here, children, I have taken 3 examples. They asked us to take several examples. How many examples you want? That many you take, such that your P by Q form where there should not be any common factor other than 1. Means there should not be any common factor. So I have taken here 1 by 2, 31 by 25, 13 by 20. Convert the given fraction into decimal. How will you convert, children? You know one method of converting a fraction into decimal, right? So another method, make your denominator multiples of 10, then it is easy to convert into decimal. So here in your denominator 2 you have. So what you multiply to get the denominator 10? 5, right? So for numerator and denominator multiply 5. It makes 5 into 1, 5. 2 5s are 10. So that will be 0.5 is your answer. It is a terminating decimal expansion. So look your second example here, 31 by 25. So observe here, children, it should be 100. When you want to convert into decimal, the denominator should be converted into zeros pattern or 10 squares pattern. You need to convert. So what you need to multiply for this 25 to make 100? 25 4s are 100. So for numerator and denominator multiply 4. Okay, so now 31 4s are how much, children? 124 by 25 4s are, it will be 100. So now how many zeros you have? 2 zeros, right? After 2 digits you place a decimal 0.1, 0.24. Okay, it is a terminating decimal expansion. Look here, third example, 13 by 20. So this denominator convert into 10 squares or 100 or 1000. How much you want, you can. So now for this 20, what you multiply to get 100? 5, right? So multiply 5 for the numerator and also denominator. That will be 65 by 100. So 25, so it will be 100. So again, how many zeros you have? 2 zeros. Numerator, after 2 digits from right side, you have to place a point. That makes 0.65. That is none other than 0.65. So look here, children, what I have taken 3 examples are terminating decimal examples only. So look here, what is your question here asked? So, can you guess what property Q must satisfy? Where is Q? Denominator. What property it should satisfy, children? Observe carefully. So, to and 5 there in the denominator. Here observe 5 square is 25, 2 square is 4. That is 5 square, 2 square there. Here 2 and 5 there. Okay. So now observe this Q here. This will be, what happens? 5, 4s are 20. 4 is again 2 square and here again 5 there. That means your Q must be any multiples of 2 and 5. It might be any number, children. 2 power m into 5 power n or 5 power m into 2 power n also you can write. If your denominator Q is in the multiples of 2 and 5, your decimal expansion will be terminating. So look here, children, any fraction, by seeing the fraction you can say whether it is a terminating or non-terminating. So let me ask you an example. 7 by 21 I will say. So what happens this one? 7 by 3 7s. 7 cancel, 1 by 3. 1 by 3, is it a terminating? No, never. Why? Observe the Q value. It's not a multiple of 2 or 5. If 2 or 5 there, any extra number should not be there again in the denominator. Either 2 or 5 or both should be there. Other than these two numbers there, then that rational number is a non-terminating decimal. You are going to get the answer when you divide. Okay, like this you need to observe, children. By seeing the fraction only, you can say whether what you get in your answer is a terminating or non-terminating. Right? Let's shift to the 7th problem here. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. So write any 3 numbers, it seems, children. How can we write? We can write the decimal numbers, right? So let's start writing here. 3 numbers whose decimal expansions are non-terminating, non-recurring. So let me take here 0.30, 300, 3000, 3000, so on like this. It is a non-terminating. Non-terminating means what? There is no end and it is not repeating. 3 examples asked. So let me write here 4.01, 1 so on, and any one more 1.05005 so on. These 3 are the examples what we have taken for non-terminating, non-repeating decimal. Yes, here 8th problem here. Find 3 different irrational numbers between 5 by 7 and 9 by 11. What are these two, children? These are rational numbers. So in between these two, you need to find 3 irrational numbers. So let's find out here. So what is the value of 5 by 7? We need to do division and we are going to find. So let's start here, children. So that will be 7, 5. So how can you divide in 7 table? You won't get 5. So for that purpose, what I need to do? I am going to take a decimal point and I am going to take a 0. It makes 50. Right? 7 table where you get 50, children? 7 7s are 49. 50 minus 49 will be 1. So now, extend. If you put a decimal point, so how many zeros you want? You can extend here. Right? So drag 1 0 down. So 7 table where you will get 10. 7 1s are 7. 10 minus 7, 3. Drag 1 more 0. 30. So where you get 30, children? 7 4s are 28. Now 30 minus 28 will be 2. Drag 0 down. 7 table where you get 20. 7 2s are 14. 7 2s are 14. So 20 minus 14 will be 6. Drag one more 0 down. That makes 60. 7 table, where you get 60, you won't get 60. 7 8s you are going to get, that will be 7 8s are 56. Okay, so now subtract this one. 60 minus 56 will be 4. So drag one more 0 down. So 7 table, where you are going to get nearer 40. 7 5s are 35. 7 5s are 35. Then again 40 minus 35 will be 5. Drag one more 0. 7 7s are 49. Then that will be 1 0. 7 1s are 7. So look here children. So from here it is repeating. Means look here. Right? 0. Point means you can write it as 0.71428571. So let me write here. What's your value? 0.714285 is your repeating. Right? How many digits are repeated? 6 digits are repeated. So one more fraction given, one more rational number given. Okay, in between these two, you need to find 3 different irrational numbers. So now, what is one more children? It will be 9 by 11. Let's start the division here. 11, 9. So what you need to do? Put a decimal point and take 0 here. Right? So now, where you are going to get here? 11, 8s are 88. So 90 minus 88 will be 2. Take one more 0. So it will be, drag this 0, 20. 11 ones are 11. So it will be again 9. Take one more 0. Drag that 0 down. So children, can you observe here? Again it will be 8, 1, 8, 1, 8, 1. That means 9 by 11. It will be continued children. Same pattern. 20, 11, 98. Like this it will be continued. So 9 by 11 will be how much? 0.81 bar. So in between these two decimals, you need to find 3 different irrational numbers. So now observe here children, 3 irrational numbers you need to find. So first of all, what is this one? It is a rational number and this is also a rational number. In between these two, you need to find 3 irrational numbers. Irrational number, do you know children what is the rule? It is a non-repeating and non-terminating decimals are called as a irrational numbers. So let me take here 71 above you need to take, right? 75 you consider. 7, 5, 3, 2, 4, 0, 1, 5, so on. Any numbers you can take. So next, any other number if you want. Let me take 0.79 I will take. Okay, 7907900779, so on. There is no end. And again 0.808008000, so on. That means you should confirm such a way that you should not end your decimal number. If you end, what happens? It will become terminating and it will be a rational number. So you should not end your decimal number and it should not be repeated. So take any numbers you take. So on, put there, so on. So on means it is a non-terminating, non-repeating. So we call these type of decimals as irrational numbers. Okay children, let's shift to the last problem of your exercise. That is your 9th problem. 9th mean, what is that children? classify given numbers into either rational or irrational. You need to classify, right? Let's see the first question there. What is the first question? Root 23. Observe here, children. If the numbers are very big, then you need to go for the square root method, apply square root, and then find out. Right? So now this is small. What is that number here? 23. Which is the nearest perfect square? Find out. 5 5s are 25. Then check it out. 23 is a perfect square? No, it's not a perfect square. So observe here carefully, children. If you have root and your number is not a perfect square, then directly you can say that it is an irrational number. Okay, so you write it here. This is an irrational number or irrational decimal. After you convert, you may get irrational decimal only. So observe here carefully. Suppose if you have root 25, root 25 can be written as 5. Then that becomes a rational number. If it is not a perfect square, then this becomes a irrational number. So next question, children, 225. Think over your perfect square table. Do you get any perfect square here? Yes, 225 is a perfect square of what? 15 15s are. Observe here. 15 15s are 225. Square will be cancelled. Then 15. What is this 15? It is a rational number. So you can write this as it is a rational number. Now next one. Look here. Observe here. Some decimal you have. Some decimal and it is terminating. Terminating means what? There is an end for your division. If there is an end in your answer, then that type of decimals are called as a rational numbers. Terminating decimal value, when you get, children, when your rational number, when you have any number in the form of p by q, where q is not equal to 0, then the decimal what you get will be terminating decimal. Terminating decimal is nothing but it is a rational number. It is what, children? It is rational number. So coming to your fourth question, 7.478 so on means what? It is a non-terminating repeating decimal. Observe here, non-terminating repeating decimal. How to convert into rational number? We have seen before, right? So what is this one, children? You can write this as 7.478 bar. So this non-terminating and repeating decimal can be converted into rational number. So therefore it is a rational number. Coming to your last and final sub question here. Observe here carefully. 1.1001000100001 so on. What is this decimal, children? What type of a decimal it is? It is a non-terminating. Non-terminating means what? There is no end. So on. Can you see? There is no end. And then it is not repeating. So non-terminating, non-repeating decimals are called as the irrational decimals or irrational number. Okay, this is also called as irrational. Finally, in this main, you have first one and last one irrational, and the three between those three are rational. Okay, children, with this we are going to end our exercise 1.3 in your number system. Right, in your next session we are going to continue with the next exercise. Thank you all.